do these a variety of ways. You could always look for a perfect square first or do the factor tree. So the square root of 160, what two factors do we use? Danielle? 16 and 10. Okay. So what's the square root of 16? 4. We can't do anything with square root of 10, so it stays as is. Okay. You're multiplying here, the two factors. If you did the factor tree, which we're going to see in a little bit, you're circling pairs. Okay. Some of you may have been taught this concept sporadically here and there, but not an official lesson like this. Okay. So for square root of 72, go ahead.
The square root of 37.
Good. What do you end up with?
6.
Good. Okay. Did anyone use two other factors? Brayden? Huh? Okay. So with 72, if you broke it up as 9 and 8, okay, this is just another way for those of you that have seen. So if I do something called the factor tree, I break it down into prime factors as far as I could go. Since we're looking at the square root, every pair I circle, one comes out. If I circle another pair, here's 2's. Whatever I do not circle stays inside, and then I multiply. 3 times 2 gives you the 6 root 2. Okay? Yes, Liam?
So all the pairs cancel the outside.
Correct. Correct. Okay. How about 3 times the square root of 75? Yep.
I can do that. So is it like just two any two numbers that multiply to 72?
Yep. Those are the factors you're looking for.
Okay.
Yep.
And I did square root of 25 and
Good. 3 square root of 25 is 5 root 3, and then you multiply 15 root 3. Okay? So whatever's on the outside, whatever pairs you take out, you multiply. Whatever's left inside, you multiply. Okay? So then we move on to variables. Okay? We have the square root of 9. X to the 9th. Sorry. How many x's do we have? X to the 9th. Assad? 9 x's. So one way, I'm going to show you two different ways. One, two, three, four. So say if I expand it out, this is just one way when they're simple like this. I'm doing the same thing as pairs, right? So I'm going to circle pair. For every pair I take out, 1x comes out. And whatever I do not circle stays inside. So then I multiply. X times x times x times x is x to what? The 4th. And then I have 1 left over. This is one way. By circling pairs. For every pair, 1 comes out. Okay? But is that realistic if you had x to the 100th? No. You'll be writing x's all day. So the other thing is we have the square root of 9, right? X to the 9th. I keep doing that. 2 goes into 9 how many times? How many are left over? That's the easier way. Yes?
Wait, so if it was like cubed, you would just divide by 30.
Correct. Because you're ultimately looking for pairs for 3 of a kind. Okay? How about for B? Okay? 2 goes into 6 how many times? 3. Good. So x cubed. 2 goes into 7. Anything left over? Okay, so whatever's left over stays inside. Okay. All right. Now for C. X squared is already on the outside. Okay? Now we have square root of x to the 8th. What do we have on the outside again? 4. So we have times x to the 4th. Then how about our y? Y to the 5th. So again, we multiply, which is adding exponents. X squared times x to the 4th is what? Good. God bless you. And y to the 5th. There you go. Okay. All right. Questions on those? So now we're going to combine variables and our numbers. Okay. So we have x cubed. How about 54? What does that break down into? What do we got? Nolan? 9 and 6. So if I was to separate it this way, again multiplying, what's the square root of 9? 3. Can I do anything with 6? Can I do anything with x? No. So those stay inside. Okay. Okay. So now for B, I have 9x to the 4th already on the outside. What am I taking out? Yeah. What's the square root of 36? I'm going to just stop you right there. Just 6, right? So you have 9x to the 4th times 6, and root x. So you have 54 x to the 4th root x. You could do 9 and 4, but just remember 3 is coming out and a 2. Okay? How about C? We have x squared on the outside already. X squared on the outside. What else? What's happening? What's that? Okay. What's the square root of 9? 3. What's the square root of x squared? Can I do anything with root 2? No. So what is my final answer? Nolan? Yep. 3x cubed, root 2. Awesome. Okay. I want you guys to try D and E if you haven't done so yet. Okay. Let's go through this. In D, what do we have for an answer? Brayden. Perfect. Good. You have 3x already on the outside. Square root of 9. 3. X to the 4th. Square root of 9 is 3. X to the 4th is x squared. Left with root 3. And you multiply. 9x cubed, root 3. Perfect. Good. For E, what do we have? Danielle. Okay. Yep. Okay. Someone else? Yeah, go ahead. Oh. Okay, Louise.
I got negative 4x cubed times y to the 4th, and then the square times the square root of 5y.
Okay, Sabrine. Okay. Esteban. Okay, Sam.
Negative 8x to the 5th y to the 4th, square root of 5xy.
Okay. Emma? Nolan? You guys are so close. So close. Very, extremely close. Okay, so we have negative xy squared already on the outside. Okay, how do we break down 80? Yeah, Liam.
Maybe not. I think we could simplify it. I guess we could do square root of 40 and then the square root of 2.
Okay, any other factors, Assad? Yep, okay. And I'm going to tell you, those of you with square root of 20 still left in the radical, can 20 be broken up even more? To what? Right, so we take 2 root 5. So keep that in mind, okay? So we could take out 4. That 5 has to stay in, okay? Now we look at our exponents. 2 goes into 9 how many times? 4. How many are left over? 2 goes into 5 how many times? How many are left over? Okay. So square root of 5xy is what you should have left. Okay. Now we multiply. We have negative 4. What is x times x to the 4th? Okay. Y squared times y squared. Here is your final answer. So, again, very close. You guys were very, very close. Those of you that had different exponents might have forgotten these guys on the outside, maybe. Those of you that still had square root of 20 just had to keep going. You were there, okay? Yeah, x to the 5th. This is x to the 4th. That's x to the 1st. And this is x to the 4th. We got x to the 4th because the square root of 9, square root of x to the 9, 2 goes into 9 4 times, and there's 1 left over. Okay, so there's 4 groups. Okay. Any questions? Okay. So, simplifying is one thing with our numerical values plus variables. Okay. Next is very simple, adding and subtracting. Okay. So, I have a question for you. Can you combine those terms to what? What do we get? Okay. Wow. That is the most and loudest I've heard this class speak ever. Anyway, how about this? No. Well, the same thing applies with radicals. The same thing, okay? You can only add and subtract if you have like terms. So that means the same inside the radical, okay? So my final answer for this one will include the square root of AB. All I'm doing is adding my coefficients together. So what is 5 plus 6? 11. So your final answer is 11AB, square root of AB. Same thing applies when you're subtracting, okay? Square root of 2x, 2x, same. So I know that's going to be my answer. 12 minus 3 is what? 9. An example that cannot be done is this. 5 times the square root of 6 plus 6 times the square root of 2. Not like radicals, not like terms. Okay. So what would happen if we have radicals that are not fully simplified? We can't combine them as is. We try to simplify first. So how would I simplify the square root of 12? Yeah, Louise. 4 and 3, and then? So we have 2 root 3 for the square root of 12. We'll combine in 1 second. 6 root 3 I can't do anything with, so that stays as is. How can I simplify the square root of 27? Esteban. Okay? Then what do you get? 3 root 3. So, these two, 6 root 3 and 3 root 3 are simplified. I just have to multiply 4 and 2. Now, do I have like terms? Okay, so 8 plus 6 is what? Minus 3. 11 root 3 would be your final answer. Okay, so I want you to try some practice on adding and subtracting 1 through 8. All right, let's go through these. The first 3 are correct. Okay, number 1, 27 root 19. Number 2, 17 root 21. Very simple because you're just either adding or subtracting the coefficients. Then for number 3, 24 root 13 minus 4 root 7. You can't combine those, so that's as far as you could go. Number 4. Did someone get something else? Addison? Negative root 2 is correct. Okay. What is the coefficient in front of root 2? 1. So I have 1 root 2 minus square root of 8 is 2 root 2. What's 1 minus 2? Okay, negative root 2. Okay, just be careful. If you don't see anything, any number in front of the square root, it's automatically 1. Okay. Then for number, what are we, 5? Good catch there. 2 root 3 plus 3 root 2. Or if you had 3 root 2 plus 2 root 3, you're correct as well. Okay, any questions on number 5? All you could do is simplify the two of them. That's it. And then number 6 is 27 root 7. Any questions on number 6? Liam?
I think the like, so I like to go 5 root 20.
Okay. So, square root of 63, how'd you simplify it?
Root 9 and root 7.
Okay. The square root of 9 is?
Root 9 is
So, for that one, I have 30 root 7, right? Okay. Now, what are 2 factors of 28?
back to 28 are, I think it's 7 and 4.
Okay, what's the square root of 4?
Square root of 4 is
2 times negative 2.
2 times negative 2 is negative 1.
Okay, so I have negative 4 root 7, and then plus root 7. Okay, so 30 minus 4?
Well, 30 minus 4 is 26.
Plus 1.
Plus 1, 27.
And that's how you get the 27 root 7. Okay? Yep, sure. And then number 7, we couldn't go any further. So that was pretty simple. And then 8, you end up with negative root 5 plus 45 root 3. Any questions on those? Okay. How many of you got all 8 of those correct? Okay. 1 wrong. Okay, good. Awesome. Makes sense? Adding and subtracting, very simple, right? You just have to break them down. All right. The next piece is multiplying. Okay, one of the rules with multiplying, if you have, say, square root of A times square root of B, that can be written under 1. Okay? Square root of A times square root of B can be written under 1 radical. Okay? All right. So, we might go a little out of order because I realized a few things last class, but we'll see. All right, so if you're given an example 3, okay, with A, you have 2 root 5 times 6 root 3. We can multiply the outside, so 2 times 6 is what? 12. Then square root of 5 times square root of 3. 5 times 3? 15. It's okay. So 12 root 15. 15 can't be simplified more, so we leave it. Okay? So multiply outside, then inside. Okay? So if we look at, we're going to skip around, A, right here, 3 root 6 times the square root of 18. Okay? You could do this a bunch of different ways. You have 3. Then what I could do is write it as 6 times 18 instead of actually multiplying. Because if you multiply, you're back to square 1 anyway, finding 2 factors. So this way, you could write them under 1. So 6 breaks up into 3 and 2. 18, 2 and 2, 9 and 2, sorry, and then 3 and 3. Let's just say. I got it down to prime factorizations. Again, multiple different ways to do this. So I have the 3 automatically on the outside already. Now I'm circling pairs. I have a pair of 3s, a 3 comes out. I have a pair of 2s, 2 comes out. Whatever is not circled stays inside. Okay. Now we multiply. 3 times 3 times 2 is what? 18 over 3. And again, a bunch of different ways we could do this. Some might choose to, with this same example, you don't have to write this down, but with this same example, some might choose 3 root 6 as is, then simplify the square root of 18, 3 root 2, right? Then multiply 9, 12, then simplify the square root of 12, which is 2 root 3, and still get the same answer. Okay? So you could do this a variety of ways, whatever you choose to. Okay? There's no right or wrong way as long as you get to the right answer. Okay? So we're going to look at, before we get to this B up here, we're going to look at this one. Okay? And we're going to do this by writing it under 1. So we first do the outside. 2 times 3, 6. Okay? Then I have 7x. I have 14. How can I break up 14? Danielle? And then I have x and x. Okay? So this one was easier to break up. Okay? I have 7x from the first one in the radical. 7 times 2 is the 14. These are all multiplied too. Do we see a pair? Do I see a pair anywhere? Louise? X and x, good. Do I see another pair of something? Say it. 7 and 7, good. Whatever I did not circle stays inside. And then I multiply the outside. 6 times 7. Okay. All right. Now we're going to go back to this one. Okay. We're going to multiply outside. And again, you could choose to do it whatever way you want. Okay. We're going to multiply. Negative 3 times 2 is what? Negative 6. Okay. I'm going to write this under 1. You don't have to expand it out like I did, but it's up to you. Okay. So now it's under 1 radical. I could do the factor tree. Okay. So how would I break up 40? Yes, I am. Okay. 4 and 10. And I'm just going to keep going to prime factorizations. Okay. All right. And I'm not going to circle anything yet until all of these are broken down. How can I break down 56? Yeah, Jack. Yep.
I break down 5 to 3 2.
That's multiplying. You're adding. It's okay. It's okay. It happens a lot. Don't worry about it. Okay. So it's pretty sloppy, but we could see all our prime factors. Okay. Now we're going to circle pairs. Remember that -6 is already on the outside. So I'm just going to carry it over. Here's -6. Okay. What's the first pair you see? Tell me. Liam. Okay, I have pair of twos. I have another pair of twos. Do I have another pair of twos? Yes. Okay. Then what else do you see? Danielle?
X cubed.
I have 1, 2, 3, x cubed. Okay, so I'm just going to combine those. -6, what do I get here? Times 2, times 2, times 2. Yep. So right now I have -48 x cubed. What is not circled? Wake up.
Oh, sorry. 5 and 7.
5 and 7, which is 35. Okay, so key component here, if you do the factor tree, cross out as you go. Okay, cross out as you go, as you break it up into prime factors. The reason is double counting, lost some factors here and there. Okay, again, this is one way. There are a variety. You do not want to because again, back to square one. If you multiply 40 times 56, you get this larger number, then have to factor it even more. Okay? Questions? All right, I want you to try C and D on your own right now. C and D. All right. For C, what did we get for an answer? For C. Brayden. Careful. Careful. Okay. So, if we had this, okay, if we had 2a9 and then a cubed, okay, square root of 9 is 3. Then we have one pair, another pair, whatever's left over stays inside. Okay, so you have 3a squared root 2. Okay, how about D? D, Sawyer. Perfect. 210 x cubed. How many of you did get that? Okay, just going through it, multiply 7 times 3 is 21. Now in this particular case, 5 and 20, if you kept it, which I saw a lot of you keep it, and expand it out this way, which is fine, okay? 5 times 20 is what? 100, and the square root of 100 is 10. You could have done that, but it's fine. If you did this, okay, this 5 is also included. You could use as a pair. So I have 21, take out 2, take out a 5, then I have 1, 2, 3 pairs, x cubed. And then I multiply. So many different ways to get the same answer. Okay? Any questions on those? Yes, Liam?
Why don't we like, in terms of like, why don't we do that same thing for 5?
5, there's only 1 and 5.
I thought we'll kind of like the 5.
Okay? So, the last thing for multiplying, just for multiplying, and then we're going to get to something else. So, when you have two binomials like this, okay, what would you typically do? What would you do in this case? Nolan? Janice? You would multiply all together, right? What is that called? With a binomial like this, Caitlin? Distributing. What acronym have we used before? FOIL. Good. So, for those of you who are not sure, you're still distributing. So FOIL is your first terms. 2 times 6, which is 12. Your outer, 2 times root 3 is just 2 root 3, not root 6 because there's no radical around 2. Your inner is 6 times root 7. And your last, root 7 times root 3 is root 21. Here we can't go any further because nothing else can be simplified. So this is as far as you could go. There, you can't go any further. You look to simplify to see if you can combine like terms. So do the same thing with B. See if you could simplify anywhere as well. Okay, go through with B. Okay, how many of you got to this point? Can you simplify anywhere? Beside where? Good. To what? Good. And we simplify to simplest form to see if we could to combine like terms. In this case, we cannot. Okay? So we are going to do some practice on multiplying 1 through 9. Go ahead. 1 through 9. All right. Number 5, you could multiply 3, 9, and 4. Okay? Then you have 6 times 2 times 10 underneath one radical. Okay? So what do we get when we multiply 3 times 9 times 4? Addison? 108. Okay, we have 108. Now, we could break down, this is 2 and 3, and 2 and 5. So we're looking for pairs, right? We have a pair of 2s, so a 2 comes out. Whatever we did not circle, 2, 3, and 5, we multiply together, okay? And that's how we get 30, and this was 216. 330. Okay. Genevieve, same question? Okay. Any other questions on 1 through 6 so far? Okay. Now for number 7, that's correct. X cubed, root 15. Any questions on number 7? Okay. Number 8, what should we have? Nolan? Good. Z, because the square root of Z squared is Z with X square root of XY inside. Okay? Spring, what do you have for 9? Then you would be absolutely correct. I thought something was missing because you.
I'm looking at it, I'm like, I'm missing this number there.
Good job. So 48 root 105. You had the 105, so I knew something there was missing. Okay, so number 9 was 48 root 105. Any questions, you guys? Okay, so we did add, subtract, simplify, add, subtract, multiply. Next, division. Yes. Okay. Same thing with division, okay? If you have a radical over an entire fraction, okay? If you have a radical over the entire fraction, it could be split up square root of A over square root of B. Only if it's over the entire fraction, okay? Anytime you're given fraction within a radical, you want to see if you could simplify first. Look for greatest common factor, see if you could simplify the fraction as you would even without the radical. So 64 over 49 there's no common factor that goes into both, right? So we would have to split it up, square root of 64 over the square root of 49. What is the square root of 64? 8. What is the square root of 49? And that would be your answer. Okay? Before we look at B, I'm going to look at C. Now, can you simplify 144 divided by 9? What do we get? 16. So you could always look to do that first and get 4. Or, if you broke it up into 2, what's the square root of 144? Square root of 9? 12 divided by 3? Still get the same thing. Okay? Are we okay? All right. So now looking at B with variables involved. Okay. Can we, first and foremost, simplify 8 over 50 as a fraction? Yeah. Okay. Hold on one second. So you divide 8 over 50 by 2. So you get 4 over 25, just for your numbers. Okay? Now, if I was to expand this out so you guys could actually see what's happening, I have 3 x's on top, 1 on the bottom. What can happen? Nolan? Perfect. Okay, so all together right now, I have 4, 2 x's, 25. Okay, so if you had 3, taking away 1, you're left with x squared. So how can I simplify the square root of 4x squared? What do I get? 2x. Good. What is the square root of 25? 5. Okay, good. All right. So if we look at D, look at your numbers first. Again, variety of ways we could do this. 36 divided by 4 is 9. And then if I have 1x on top, but 3 on the bottom, God bless you, what can I do? Cancel 1 out. What's the square root of 9? 3, thank you. Square root of x squared. And again, a variety of ways. Okay. Try E. Yeah, Liam.
Why do we square it twice? Like, I can make it, maybe that's, because there's like, we get rid of an x. Oh, that's why I did it.
We're dividing first and then simplifying. We're simplifying the fraction, then simplifying the radical. That makes sense. Okay. Try E. Okay. Square root of 25y cubed would be what? Assad? Good. 5y times the square root of y. Everyone see that? Everyone okay? All right. Square root of z squared. Z. Good. Awesome. How many of you did get that for your answer? Good. All right. So, obviously, it's not all peaches and rainbows like that, right? Okay, peaches and rainbows, that's not even a thing. Anyway, okay, when we're dividing and you cannot simplify the fraction, anyone know what to do here? 1 person, 2 people, 3 people, 4 people. Genevieve, go ahead. Perfect. Because the rule is, can we have a radical in the denominator? No. So we rationalize. That's what it's called. By multiplying square root of 7, top and bottom. Okay? What's the square root of 3 times square root of 7? Danielle? Good. Because how do we get 7? Square root of 7 times square root of 7 is what? Square root of 49, which ends up being just the number inside. Some people may ask, can I divide 21 by 7? No. Why not? Perfect. Good. Try B. Okay. B, what do we got? Louise. Careful, you're doing it again. Multiply, multiply, multiply. It's okay. Multiply, multiply, multiply. Square root of 6 over 3. Okay, it's all right. So, with C, you could multiply top and bottom by root 8x, right? We could, but then we have to simplify at the end. So, what I'd like to do, and you guys can do it your own way, is I would like to simplify wherever I can first, before rationalizing, okay? And I'll show you why in a little bit. So, how can I simplify the square root of 8? Because I know that could be simplified. Yeah, Nolan. Okay, simplify it. You know it. Perfect. Okay. So, if I rewrote square root of 8x by 2 root 2x, the x has to stay because I can't take that out, then what do I only have to multiply by? By the square root of 2x, right? Okay, so what is 7 times 2x? 14x. Then what would I have in my denominator right now? Cyan? 4x, good. Okay. Okay. So say if you didn't do that, okay, which is fine. Like say if we took D, for example, and we didn't simplify the square root of 18, and I multiplied top and bottom by root 18x, which is fine. You could multiply 5 times 18 and then simplify, okay? I know my denominator is going to be 18x. How can I simplify? How can I simplify that? Well, 18 breaks up into what? What does that simplify to? Yeah. 3 square root of 2. But since I have that 5 there, so this is what it looks like. 3. Then I have 5. It's 2 times x over 18x. So I have 3 times. Can I simplify anywhere? Yeah. Yep. Which we would have got the same thing if we, from the beginning, it simplifies already for us. If we did 3 root 2x and multiply top and bottom by 2x, you get straight to this answer. Okay? That's why I like you guys simplifying first, then moving what's left. However, can you do it both ways? Yes. As long as you simplify your fraction. Okay, does that make sense? Yeah, Liam?
Received 4. So y complete is 2. Y complete is 2 root 2x times 2x equals 4x.
Because if you have the 2's already on the outside, right? Square root of 2x times square root of 2x is 4x squared. Square root of 4? Square root of x squared? So you end up with whatever's inside. So it's 2 times 2x to get 4x. Make sense? Okay. Okay. All right. So the last thing is this guy down here. Okay. Now, what do you notice that's different about this? You guys just look at A and B. What's different compared to what we just did above? Jack? Okay, good. What else? Yeah, I skipped the last one, you guys. You're not going crazy. I skipped the last one. Yeah, don't worry. Okay, so one term has the radical, right? What else do you notice? Danielle? Right, so we have a real number of some sort, right? We have an expression in the denominator. So one term has square root, the other does not. So in order to get rid of that radical in the denominator, we have to multiply top and bottom by the conjugate. Okay? The conjugate is the opposite. Okay, so what that looks like, I'm multiplying top and bottom square root of 5 plus 1. The only thing that changed was what? Ellen? The sign in the middle. Okay? So I'm going to write it as one fraction. Okay? This is what it looks like as one fraction. So what would I have to do in the numerator? Esteban? Good. 3 root 5 plus 3. So that's distributing, right? Then the denominator looks like what we did for multiplying, right? We're going to go all the way through so you see what happens. So what is the square root of 5 times square root of 5? 5, good. Okay. Square root of 5 times 1 is just the square root of 5. Negative 1 times square root of 5? Negative root 5. What's negative 1 times 1? Negative 1. What do you guys notice? Esteban. The square roots on the bottom cancel out. So you're left with 3 root 5 plus 3, and then 5 minus 1, which we could simplify to what? Good. Okay. Some of you might see some shortcuts as you're going through this. And the last one, what are you multiplying by? And you guys are going to try it. Danielle? Yep. All right, go ahead. Do it out. 9 minus the square root of 2 is the... How many of you did get this as your final answer? Negative 27 plus 3 root 2 over 79. Did you realize too the shortcut in the bottom, hopefully, maybe, where you can multiply knowing that they're conjugates, so knowing those middle terms will cancel out. 9 times 9, 81. Square root of 2 times negative square root of 2 is just negative 2. Okay? Some of you, it's great walking through the process. Is awesome. And then cross those out. Good job. All right, you guys, we did a lot of operations today with radicals. Your homework is on that next page, the 2.3 practice. It's all. Some of the answers might be blocked out. That still means to complete. Okay? 2.3 practice. Some of the answers might be blocked out, but still complete those. Right? Awesome job, you guys.